G'day. Every so often someone comes along and asks if I can make something up for them, and usually there's a bit of concern about how long it takes, what they're going to pay, all that sort of thing. Today, or the last few days, I've been making up some little gears, change gears for a lathe, and I thought it'd be interesting just to break down what goes into that so that people have an idea as to, well, why does a small part cost so much? Another thing that people forget about is the cost of materials. Steel is relatively cheap, but things like aluminium aren't. And so this particular block here, it's 100 millimeters by 100 millimeters by 80, so it's not enormously big, but that's $20. Now I had someone come up and say, can I make them a bracket for whatever it was? And when I said, well, for a start, the materials are going to cost you around about $30 to $40, he suddenly retreated because he was expecting something that included my labour, probably all up $20. If this was a lump of wood, that might be actually true, but metal is expensive. Steel not so much, but when you start getting into aluminium and stainless and always coppers and bronzes and brasses, things like that, the cost soon mounts up, and that's even before you take anything off. So here I've converted the mill over to horizontal. It's my preferred mode for cutting gears, but it's taken me about 15 minutes to do this. You can imagine, and I'll check this when I turn it back, that once you've converted this way, you will take a similar time to get back to the way it was. Now, this is one reason why I try to do things in batches, so that I'll wait until I get 3 or 4 gears come through, because if I did this for one gear and then changed back and then for another gear, it had taken an enormous amount of time. So even by doing, say, 3 gears at once, I'm potentially saving myself an hour and a half worth of setup and breakdown time. I've got the dividing head bolted to the table, but I'm still to set that up, so that's going to take another, well, we'll find out. To make sure that's true, to mount the work on there, get everything ready to go, and all just to cut some gear teeth. The dividing head is now set up. I've got the division plate all properly assembled. I've got the blank in place. I've got the cut in the right spot, right direction. I'm pretty much ready to cut a gear, and that took around about 20 minutes to do that. So here we are, first gear done. That took around about 15 minutes. Now it's a 28 tooth gear, so you can probably say 30 seconds per tooth. They're reasonably small teeth. There's still got to be some cleanup on that though. There's got to be, I've got to take the burrs off on the wire wheel. In this particular case, the bore needs to be taken out, but I won't count that in the estimation. And I need to put a keyway in. I'm already set up for the next gear, so we'll continue on. I've got to change some wheels, but I'll continue on. I've just finished tramming the mill up, and it's around about 25 minutes to take it from set up horizontally back to vertical. So there's another 25 minutes for the tally. I've just finished machining my adapter piece. The outside width is critical because that's got to fit in there, and the inside width is critical because that's the brooch has got to be able to slide in there. If that's too sloppy, then the keyway gets chewed out, so you've got to watch that. In terms of depth, what you want is for it to be flush, on the basis that that's all going to go into a clean bore, and then you're going to push to take that out. And as you can see, the brooch doesn't take much out, so you've got to do 2 or 3 passes with that. Similarly with this one, the depth just has to be enough to clear that so it doesn't interfere with the bore. I've put a little fillet, chamfer on the corners there and there, so I can get a screwdriver in to get that out, because it is a tight fit. One thing I had to do, as you may be able to pick up, the brooches have got sharp corners on them. So one thing I had to do was run one of the thin angle grinder discs just down there to clean up the corner, make sure that I had clearance there. Probably could have used a Dremel, but the angle grinder was closer. But as a result, I've now got an adapter which will enable me to put a B1 size brooch into a C size bush. Another thing worth noticing too, I've got my adapter in there ready to broach, and I've got my brooch. But if you look at the thickness of the gears, they're only 10mm thick. That's barely 2 teeth, and so what I'm going to do here is stack up all 3 gears and broach them all at once. Okay, the reason for that is just that way I get more teeth in the cut. It's a bit more stable. It's a bit like saw teeth, as I talked about in my bandsaw video. 3 gears made, and I've got the trusty whiteboard out to total up the time. Now that's for 3, and that's for 3, and that's for 3. But when you look at it, that's 190 minutes to make 3, and that doesn't include the time for making up little bits of tooling, like the adapter for the brooches and all that sort of thing. So it's a little over an hour a gear. But when you look at the actual cutting time, if you take your broaching and the actual gear cutting itself, that's what, 80 minutes, so less than half of that. And I guess that's what I'm really trying to say here, is that there's a lot of setup involved in making things. So even if you think that a small part such as that, shouldn't cost a great deal, the chances are that it will. And so when you go to a commercial gear cutter, that's what they're charging for. It's not necessarily the steel, and there's probably $1 worth of steel in there, but it's all the time to set up the machines, it's all the time to operate the machines that cost you money. Anyway, I hope that's been helpful to people, so that next time they get something made, they have an idea as to exactly why it costs so much. It's been an interesting exercise to tally it all up, but thanks for watching.